want to use this medium to appreciate all our subscribers, all our viewers. I want to say thank you so much for watching our videos, for liking, for your comments. And if you are new in this channel, kindly subscribe. Make sure you turn on your notification button so that whenever we release videos in this channel, you'll be able to see it. And then likewise, you can share the video, drop your comment to any secondary school student that you think will be in need of this video. Thank you so much.
I will blow your mind.
Now, if you are preparing for this year NECO GC or WAEC GC, I want to tell you that you are in the right place. We want to quickly consider this question as a practice question for this year NECO and WAEC GC. Read with me. It will be displayed on the screen there. Alternative to chemistry practical 2022. Now we have this practice question. A is a solution containing 2.52 grams of hydrochloric acid. Hydrochloric acid, that's our acid. Hydrochloric acid per dm cube. So 2.52 grams per dm cube. That's the mass count we are given. And that mass count is for hydrochloric acid. Okay? B contains 3.01 grams of hydrated sodium triazocarbonate 4. Hydrated sodium triazocarbonate 4. And that is our base. In what? In 250 cm cube of the solution. 3.01 grams in 250. Now, normally it should be per dm cube or in 1000 centimeter cube. So, like that, we are going to do unit conversion when we get to that stage. So, if 25.0 cm cube of hydrated sodium triazocarbonate 4 neutralized. Now, there are two things here. One, this 25.0 cm cube is what represent the volume of base, which is the volume of the sodium triazocarbonate 4, and 30.050 cm cube represent the value of what? Of the base. No, excuse me. I said 25.0 cm cube is the volume of the base, while 30.50 cm cube is the volume of the acid. And what our acid? Our A is what? Hydrochloric acid, while our P is sodium triazocarbonate 4. Sodium triazocarbonate 4 X water is hydrated salt. Anyway, it's hydrated salt. Okay, now this is the equation of the reaction. Sodium triazocarbonate 4 plus 2 mole of hydrochloric acid to give us this product, which is sodium chloride, water, and then carbon 4. Now, from this information, we have to calculate concentration of A in mole per dm cube, B in gram per dm cube, and then B in mole per dm cube.
I will blow your mind.
Okay, like I said, one of the indie facts in alternative practical is that it's possible you are not given the table, but from the question you will know the title value. It's possible that there is no table in the question, but if you read the question very well, the title value for the acid must have been given. So one of the hidden facts is that make sure you read the question carefully to determine the title value of the acid provided that you were not given the table, provided that the table is not in that question. So first thing we are going to do right now is that the question is asking us to calculate conc of A in mole per dm. And remember, molarity. Another interesting fact is that molarity is the same thing as concentration of acid or concentration of base. So molarity is equal to gram per dm cube over gram per mole. Gram per dm cube over gram per mole. Now gram per dm cube means mass concentration, while gram per mole means molar mass. Molar mass. So, and what's the unit of molarity? Molarity is expressed in mole per dm cube. That's the unit of molarity. Whether you are calculating for acid or you are calculating for base. Now here, since we are calculating for acid, which is A, that will be molarity of A is equal to gram per dm cube of A over gram per mole of A. And remember that our A is what? Hydrochloric acid. Our A is hydrochloric acid. So from the information provided, I will display the question again on the screen. From the information provided, we were given 2.5 gram, 2.52 gram per dm cube of what? Of acid. So in that case, concentration of A, let's represent it with Ca. Concentration of A is equal to gram per dm cube of A has been given, which is 2.52 over now molar mass of A. Molar mass of A, our A is hydrochloric acid. So if you want to calculate the molar mass of A, we are going to add their atomic masses together according to that formula. And in that regard, the atomic mass of hydrogen is 1 plus the atomic mass of chlorine is 35.5. 35.5. So like that, this question, you get 2 marks here. 1 mark for correct substitutioning and 1 mark for what? 1 mark for calculating molar mass. Ensure that you show your workings. Every workings you are doing in chemistry, make sure you show it before you can get the accurate mark. If you just bring this molar mass, you work it on somewhere and just bring it here, it will not stop. So that's why you must show it. And by the time we calculate that, our CA is what? If you press your calculator, our CA will be equal to 0.0690. And what's the unit? The unit is in mole per dm cube. The unit is in mole per dm cube. So our final answer, our CA is 0.0690 mole per dm cube. For you to get mark for this one, it must be in 3 significant figure. Because 0 starts here, that's why I write it this way. If it is a real figure, it must be a 3 significant figure. So for you to have 1 mark here, it must be in 3 significant figure.
I will blow your mind.
Now the next question says concentration of B in gram per dm cube. You need to be careful of the unit in gram per dm cube. So if you are calculating concentration in gram per dm cube, the formula to use is quite different from when you are calculating concentration in mole per dm cube. No, so in this case now, if you check the question, we were given mass of B, which is 0.1 gram. But the question says that it dissolves in 250 cm cube. In 250 cm cube. And the standard value is that this mass supposed to dissolve in 1000 centimeter cube, because 1 dm cube is equivalent to 1000 centimeter cube. Do you understand now? So in that case, in 1000 centimeter cube will give us X mass. What we are just doing right here is that we want to convert this mass, which is 250 centimeter cube, into gram per dm cube, because that's the standard value, that's the standard unit we are going to use whenever we are dealing with titration, or whenever we are saying mass concentration. So if you do your calculation like this, you are going to earn yourself 1 mark for this expression. Then making X, which is this mass we want to convert, making X the subject of the formula. So when you are making X the subject of the formula, is simple. You just do cross multiplication, which means that the X times 250, which will give us X 250 into bracket, is equal to 3.01 multiplied by 1000. So you divide both sides by 250 in order to make X the subject of the formula. Divide both sides by 250. So finally, X is equal to, by the time you press your calculator, what's your answer? If you press your calculator, which answer did you get there? If you press your calculator, you are going to have 2.04 gram per dm cube. Gram per dm cube. If you press your calculator, you are going to have 12.04 gram per dm cube. Please take note. It's better for you not to put unit than to put wrong unit. If you put wrong unit, you will be penalized for it. That's another hidden fact. It's better for you not to put any unit if you do not know the right unit to put there than to put wrong unit. So right here, if you put gram, if you put gram per mole here, it is wrong. It will not stop. Or if you put mole per dm cube here, you miss the final answer. So making X the subject of the formula here is another 1 mark, and then your final answer here will fetch you another 1 mark. So from the question asks us to calculate concentration of B in gram per dm cube. So right now we have calculated conc of B in gram per dm, which is 12.04 gram per dm cube.
I will blow your mind.
Concentration of B in mole per dm cube. Don't forget to calculate concentration of A in mole per dm cube the other time. And we use molar, which is the same thing as CA or CB is equal to gram per dm cube of this one now, gram per dm cube of B over gram per mole of B. Now let's see. We have two options. We have two formulas that we can use. Is either we use the first one, which is CB is equal to gram per dm cube of B over gram per mole of B. Remember that gram per mole is the molar mass, and then gram per dm cube is the mass concentration. Now, if you check the question very well, now we have calculated gram per dm cube of B, but gram per mole of B, can we determine that, which is the mass the molar mass of B? Can we determine the molar mass of B? Of course no, because the formula given was Na2CO3 dot X water. Now this X, we are yet to discover what X represents, and because of that, there is no way we can calculate the molar mass of this formula. In that case, we can't use this formula, just because we cannot determine the molar mass. We cannot determine the molar mass. Because we cannot determine the molar mass, we won't use this formula. Then we'll rather go for Savannah, which all of us, I know you are conversant with Savannah, right? Now, Savannah, this Ca is the concentration of acid. The concentration of acid that we calculated the other time, which is 0.0690. That's the concentration of acid that we calculated the first time. multiplied by the volume of acid. If you check the question, that was what I said earlier, and that's another hidden fact, that when you are reading the question, you read the question carefully to determine the values you were given. Please take note of that. You read the question carefully to determine the value you are given. Now, from my list here, the VA that we are given in the question is 30.50. That's the volume of the acid. Do you understand now? The volume of acid is 30.50 divided by concentration of B. Remember, that's what the question asks us to calculate. So we don't know it. Multiplied by the volume of B is constant. That's the volume of the pipette, and it is 25.0. Is equal to, now if you go back to the equation of the reaction, the mole ratio of acid to base is 2:1. Acid is 2. That's the number that we use to balance that equation, while the base is 1. Please take note. Some of us, we know this formula already. We know that this is the formula we are going to use. We just make CB the subject of the formula straight away. You will lose mark like that. So if you do it like this, you are going to earn yourself 2 marks. And what is the 2 marks there? This mole ratio is very important. 2/1, 2:1. It will give you 1 mark for doing so. And correct substitution, that you do not give VA for VB or VB for VA. Correct substitution will also earn you another 1 mark. So in this question like this, you have 2 marks already. The next thing is that we are going to make CB the subject of the formula. And when we are making CB the subject of the formula, we are going to cross multiply. We firstly cross multiply, and please take note of this. When you want to cross multiply, it's not important for you to do it like this. If you do it like this, you have already cancelled your work. So better still, don't put any cross multiplication, but you can cross multiply. If you cross multiply, that means that the base here multiplied by the numerator. So that means that the CB, we can open bracket for 25.0 multiplied by 2 close bracket is equal to, you multiply everything here by 1, which is 1 multiplied by 0.0690 multiplied by 30.50. Remember what we did the other time? We just divide both sides by what? By 25 times 2. We know that 25 times 2 is the same thing as saying 50. So just divide this one by 50. 50.0. So eventually our CB is equal to what? Oh yeah, press your calculator. What did you get? And tell me the answer. What did you get? Our CB is equal to what? What's the answer? 0.0421. 0.0421. Remember that we are calculating CB. We are calculating CB, so it must be in mole per dm not in gram per mole. So here, making CB the subject of the formula, it will hand you 1 mark. Making CB the subject of the formula, you get 1 mark for it, and then correct significant figure here. It must be 3 significant figure. 3 significant figure. You earn yourself another 1 mark. Do you understand now? So from there, we've calculated our mass concentration of B, and we have calculated molarity of B.
I will blow your mind.
The part B of the question we just calculated now is this. The question asks us to determine the number of molecules of water of crystallization present in this. So when we say water of crystallization, actually the question is asking us to calculate this. The question is asking us to calculate the value of X. Okay, then the BII of that question says we should write the chemical formula of this after we have determined the value of X. The first step the first step here is this. Listen. The first step here is this. You are firstly going to determine the molar mass of this formula, Na2CO3.X water. We firstly determine the molar mass. And how can we determine the molar mass? We can just bring out the equation that relates molar mass and mass concentration. Molar mass and mass concentration, and that is our Cb is equal to gram per dm cube. Remember, we have calculated that over gram per mole, which is the molar mass we want to determine now. So we substitute the formula, the value we have gotten into the formula now. We substitute the value into the formula. Okay, now we've determined Cb, which is our Cb is 0.0421 is equal to, remember that we have determined the mass concentration too, which is 12.04 divided by gram per mole. That's our molar mass. So the next thing we are going to do here, we make molar mass the subject of the formula. That means that we are going to cross multiply. So if we cross multiply, we are going to have gram per mole multiplied by 0.0421 is equal to 12.04. So making gram per mole the subject of the formula there, you are going to have our molar mass will now become 12.04 divided by 0.0421. So our molar mass is equal to, where place the calculator. If you press this should give you at approximately figure of 286 gram per mole. Note, for you to get this mark, it must be a correct unit. You earn 1 mark for this, and then for this final answer, you earn another 1 mark. Now, the addition of the masses here is what we call the molar mass, which is 286. So the next thing we are going to read here is that our sodium is 23 multiplied by 2, these 2 atoms, plus our carbon is 12, that's the atomic mass of carbon. The atomic mass of oxygen is 16, but how many atoms of oxygen do we have here? We have 3. So that will be 3 multiplied by 16. This dot means plus X. If you calculate the molar mass of water, oxygen is 16. That's the atomic mass of oxygen. Hydrogen is 1. 1 multiplied by 2, that is 2. So 2 plus 16 is 2. So the molar mass of water is 18X, because we know X here is equal to 286. So if you add all these things together here, we are going to have 106 plus X18 is equal to 286. Remember mathematics now. Collect the like times. X18 is equal to 286 minus 106. What's your answer? Minus 106. What's your answer? You are here to tell me the answer. That means X18 is equal to, so if you minus 106 from 286, it's going to give you 180. So divide both sides by 18 in order to get the value of X. So X is now equal to what? 10. X, that's the value of X. X is equal to 10. Now, so we've calculated the value of X to be 10. Now, the question says you should write the correct formula. You just say Na2CO3 dot 10H2O. Please remember, my students or my viewers, if the question does not ask you to write the name, please don't write the name. The question actually finished by saying we should write the formula, not name. If you are writing name now, this is sodium trisulcarbonate for decahydrate. But the question is not asking us to write the name. So it's just asking us to write the formula. And here comes to the end of this question. Next week we'll be looking at the SWOT analysis, alternative to practical of the SWOT analysis. If we have added value to you in this video, please don't hesitate to give us a like, then smash that subscription button right now. We are going to give you updates on chemistry practical. Strike that button right now.